thank you. And I also would like to thank Wolf and Xiaojie the introduction to my today's talk. Today I would like to talk one of my recent works when I work as a postdoc scholar at IIASA, which I work with Xiaojie Society, OK Brosco, and Wolf. And today my talk will carry first carrot, then see how the adaptive hybridization of the incentive promotes cooperation. And maybe today my talks, because Wolf and Xiaojie already gave some detailed introductions about the punishment and the rewards. Also yesterday, Professor Howard introduced the punishments monuments to you. So today maybe my talk is a little technical. And but before that, I would like to still want to give a background to this study. So as you may know, cooperative behaviors are widespread in the real world, including the social, economical, and political systems. But however, according to Darwin's theory, evolution should be based on competition, not cooperation. This shows that an individual's cooperative behavior benefits others, but incurs cost to itself. So how can we understand the emergence and the persistence of cooperation is a central problem. And fortunately, evolutionary game theory provides a powerful mathematical framework to solve this problem. And traditionally, the problem of cooperation is studied by means of game theory models, especially of the prisoner's dilemma or pairwise interactions. But more generally, the public push game for the multiplayer interactions of individuals. In particular, the public push game is abundant in human society. For example, for protecting the global climate and also to avoid the overfishing of the oceans. So, the public push game is recognized as one of the promising tools to study the tragedy of the common goods. And here I want to introduce some background of the public push game. And in the classic public push game, so individuals engage in multiplayer interactions and then decide simultaneously whether to cooperate or defect. If they contribute, the cooperators need to contribute a fixed amount to the public good, but for defectors, they contribute nothing. And then correspondingly, we can write the payoffs for defectors and cooperators in a group. We can see that defectors can have a higher payoff than cooperators. And for study, basically for study the evolutionary dynamics of corporations in populations, we can use the replicators dynamics for well-mixed populations. So this is the replicator dynamics. Based on the analysis of the replicator dynamics, we can see that the defectors can always dominate the cooperators in well-mixed population and drive the population to the tragedy of the commons. And actually, we know that if the populations could be most successful if everyone cooperates, so there exists a social dilemma. And in the past several decades, so many studies focus on to promote the mechanisms for the evolution of cooperation and want to solve the problems of cooperation. And recently, so social institutions are widely recognized as a successful means for promoting cooperations. And as you know, institutions often use rewards and punishment for providing incentives. And especially for the institutional sectioning, actually is very wide theory in human society. But to my knowledge, only a few theoretical studies have thus far focused on the effects of institutional last incentives on the evolution of cooperation. In particular, so my colleagues Tatsuya Sasaki and also other colleagues, including Dickman, Kashima, and OK Brownstone, so recently proposed a new scheme for the instituting, rewarding, and punishing, as Wu talked in his talk. So I think here I should skip this because Wu have mentioned this, and I want to point out the main results of this study. I think I understand that. So when the optional participation is introduced, it's found that institutional punishment can overcome social dilemmas at a very lower cost than instituting rewardings. But for me, so this is very great work, and based on this work, we can continue to have some ideas and thoughts. That is, so because we understand that because in the real world, the results are limited. It means that the budget, incentive budget, is also limited. So providing the incentives is costly. So for this limited world, it's very important to find the efficient policies for maybe for the combined use and the synthesis of rewards and penalties. But however, the current existing studies only consider the rewarding of punishing in isolation. So, and they also did not consider how the optional incentives change with the system state. It means that the policies, the proposed policies in these studies may not be the efficient ones. And moreover, as Professor Horace mentioned in his talk, so in some public good schemes in human society, maybe optional participation is forbidden. For example, for the climate change gap, mandatory participation should be considered. So based on these motivations, here we just do some work based on this assumption. So we only consider two strategies in the classical public good scheme. And we continue to assume that the incentive budget can be separated into two parts. And the first part here, and delta omega is for rewarding cooperators. And the left part is used for punishing defectors. And here omega is the relative weight for rewarding. And I want to stress that here the relative weight is dynamically changing, which depends on the system state. Here we consider it depends on the fraction of the cooperators. And accordingly, so the payoffs for individuals in a group can be described in this form. And here omega is the relative weight. And and then we also introduce two additional parameters. Here A means the efficiency factor of rewarding. B is the efficiency factor of punishing. And we first want to use the replicator dynamics to analytically to find the basic form of the omega x. That's to find the best policy. And we know that from the replicator dynamics, the selection gradient is maximum. Y is maximized. That means when the payoff difference between defectors and the cooperators is minimized, maybe the best form of the omega x can be determined. And here, the payoff difference can be written in this form. And we notice that this is the linear equation in omega. So we can easily note that the best value of omega could be either 0 or 1, which depends on the expression in this red rectangle, whether it's positive or negative. And then, accordingly, we can find that when the on-off control of incentives is present, then the payoff difference between the defectors and the operators is minimized. And then the best form of omega x can be described in this way. So that is, if the fraction of the operators is less than x hat, then we should choose rewarding. Otherwise, we should choose partition. And here x hat is the switching point. And also x hat is the unique interior point of this expression. And then we can clearly plot the optimal omega x in this sketch figure. And here I want to mention that here x hat actually is independent of the per capital incentives and also independent of the public benefit factor R. And then because we can see that here the best policy is depends on the switching point x depends on the fraction of operators of the system. So if the fraction of operators is less than switching point, then we should choose rewarding. Otherwise, we should choose partition. And then we directly call this proposed policy first carrot, then stick. And we also consider this is the adaptive feedback function. So then we also call it adaptive hybrid policy. And in this work, our goal is to study whether this proposed policy is better, or whether it's the best one for saving some incentive cost by comparing with the pure rewarding or pure partition policies. And we used we defined a policy's effectiveness and efficiency as the criteria to answer this question. So here I want to introduce the definition of the effectiveness and the efficiency. So by effectiveness, we mean the parameter range for which fork operation can be established or recovered. And by efficiency, we mean the cumulative cost and the total time required for converting a community of defectors to fork operation or for recovering fork operations from evasion of a single defectors. And first, we show the effects of the three incentive policies on the evolution of cooperation in world-mixed population. We know that for an efficient policy for promoting cooperation should overcome two challenges. First one is that to ensure cooperators can gain a foothold in a community of defectors. And the second one is to protect corporations from exploitation by defectors once cooperation is established. And basically, we know that for small incentives, the evolutionary outcome should be the full defective. And for sufficiently large incentives, the outcome should be full cooperation. But for the incentives, for the intermediate incentives, the solutions for these three different policies are different. And we can see that, so under the period wording, and the systems has a unique interior point, which is stable. And we can see that in one mixed population, the outcome is independent of the initial condition. And under the pure partition, there also exists an interior equilibrium, but it's not stable. So the system is best stable. And accordingly, the outcome can be influenced by the initial condition. And under the adaptive hybrid policy, the system has two interior equilibrium. And the one with a small fraction of operators is stable. And then we can see that so when the initial condition is a single defectors, the domains of full cooperation is equal to that of the partition. But for the single operators, the domains of full cooperation is much larger than that of the partition. Overall, we can find that the domains, the adaptive hybrid policy has the largest domains of full cooperation, both in these two special initial conditions. And we consider that for this institutional sections, formally is specially distributed. Then we continue to study these three policies in the special populations. And we can find that still in these special populations, the adaptive hybrid policy has the broadest domains of full cooperation, both for the establishing cooperation and also for recovering cooperation. And then we can conclude that this proposed adaptive hybrid policy is the most effective policies among these three. And regarding the cost for the establishing and the recovering full cooperation, we know that so when a state of full cooperation is established, partition is cheaper as a means of, so this partition is much cheaper because in this situation, parchment is only used occasionally. So we can see that in this second column, in this initial condition of a single defectors, basically the adaptive hybrid policy has the similar cumulative cost with to that of the partition. But for another special initial conditions, the two policies of adaptive hybrid and partition have a totally different results. And overall, we can still find that the adaptive hybrid policy has the lowest cumulative cost, both in establishing full cooperation and recovering full cooperation. And this results also valid not only in one mixed population, but also in special populations. And we can conclude that so this adaptive hybrid policy is the most efficient policy. But regarding the time for establishing and recovering full cooperation, we find that under the same initial condition, basically it takes a similar finite time to establishing cooperation or recover cooperation. And Now we can conclude that this proposed adaptive hybrid policy is not only the most effective policy, but also the most efficient policy. And but why is adaptive hybrid policy is better? Here I want to show you some typical emerging patterns of cooperators, especially for some intermediate levels of incentives. And for rewarding, we can easily know that for small or incentives, basically very small or zero incentive, basically for defecting is the outcome. But for large incentives, for cooperation is the outcome. Here I want to show. So because this lead areas is very sensitive areas, so I want to show the emerging patterns in these areas. And we found that so under the rewarding for the intermediate for the rewarding, so initially there is only a single these are single operators, and under the rewarding, so we found that these operators can only form very small patches, and these clusters are very small, and it's not sufficient to support operators to dominate the whole population, but they can survive with the defectors. But we can find that rewarding has the advantage, that is, it can inspire corporations. And under the punishment, we find that only for the large enough incentives, the corporators can gradually form a compact cluster from the initial condition of a single operators. And the delta values here should be about 0.75, but for adaptive hybrid policy. And we can find that at the beginning of the evolution, so in these local patterns, we can find that here are some fragmented islands of cooperators. When these cooperators clusters is large enough, because we can understand first, this is used the rewarding, but then this clusters is large enough, this can inspire the institution punishment. It can spontaneously switch from rewarding to punishing, and then make the punishment works. And this punishment can just work as a booster stage. This booster stage can amplify the social effects of rewarding. And then we can find that these clusters can gradually grow, and finally becomes larger and larger. Finally, can formulate the whole populations. So, from this comparison, we can conclude that why the adaptive hybrid policy is better. This is because that it can combine the effectiveness. It can combine the effectiveness of rewarding in establishing cooperation, and with that, with the effectiveness of punishing in recurring cooperation. And finally, we want to make a conclusion of this work. So we find this adaptive hybrid policy And this policy established and recovers foreign cooperation at a lower cost and under a wider range of conditions than either rewards or penalties alone, in both in war mixed and special populations. And this adaptive hybrid incentives offer the best of the both worlds. That is, by combining the effectiveness of rewarding in establishing corporations with that of punishing in repairing, thus provides a surprisingly expensive and widely applicable method of providing corporations. And finally, thank you very much for your kind attention.
Thank you, Xiaojie. Very good. Would you like to ask a question? We need a microphone here.
So thanks for your lecture. I noticed that in your PowerPoint that for only rewarding the result seems robust with the initial conditions, but for only punishment, the result seems sensitive to the initial conditions. Can you explain that?
Yes. I think this is because, especially I think for the intermediate level of incentives, because for rewarding, so for rewarding, because there exists only Unicode integral equilibrium, which is stable. So it means that the outcome is independent of the initial condition. But for punishment, this system is best stable. So it means that the outcome should be influenced by the initial condition. So for this, a single operator's initial condition, it means that for this part, so full defection should be reached. But for this, a single defectors, it means that the fraction of operators is much higher initially. So it means that the full operations should be the outcome.
And another question? Yeah, let's go to the microphone. Very good. Let's take it from the back, please.
I have a question. When you consider the reward before the PPT is the first part, the start part. The next one. And the reward, where the reward is n times delta divided by nc minus delta.
Okay.
Yeah.
So we assume that because this reward is working only for a group of players, and we just assume that this delta is an incentive cost imposed on each players, just like work as a tax. So each player should pay a tax for this delta, and then the group member, the number of group members is n. So the budget totally is n delta. So this is the basic assumption from the Xiaojie party's work.
Thank you.
Yeah, I see a question there in the back. Oh, sorry, could I just take another question because you already had yours? There's one here in the middle.
Thank you for your exciting report. But I want to know how did you decide the critical point between rewarding and punishment? So the switching point, how did you decide?
The switching point is determined by this, because this is the linear equation in omega. So we just think omega is as the parameter, and it's a linear form. So here, for this switching point x hat is the unique interior point of this expression in the reader rectangle. This part.
Okay, then we have time for the last question. In the back right, please.
Thank you. So, how about the heterogeneous network, such as small world network and scale-free network?
Currently we do many robustity check, including the population size and abstractly updated rule, but we currently do not introduce it into the scale-free network in a small world networks. But I believe that it should be also works. But maybe later after this talk we will try that.
So now no one do that.
Sorry.
So no papers about your model for the scale-free and our small world?
Because for to my logic, maybe no.
Okay, thank you.
Right, then I would suggest we thank Xiaojie once more. Thank you very much.